This is Mr. Beck Does Your Homework. This is AP Physics, Homework 2.3 for 4 equations of motion. This is a 3-part question, so questions 8, 9, and 10. All I'm going to do on the same one. It says a car moving westward along a straight level road. Well, wait a second, westward. Why do I care about that? Oh, because eastward is positive and westward is negative. So I'm going to use that as east is positive and west is negative as I write down my numbers. A car moving westward along a straight level road increases its velocity uniformly from 17 meters per second to 36 meters per second in 11.9 seconds. What was the car's acceleration? Now, I know I told you west is negative and east is positive, but here it's giving me a plus 17 and a plus 36. So it will get confusing unless we actually, in this case, let's make west positive and east negative. Is that okay? Sure it is. Physics works that way, where you can switch all the negatives and all the positives and you'll still wind up with the same answer, with a right answer. You can even make time run forward and backwards, and physics works the same both ways. So we're going to define west as positive and just go with it. So a car moving along a straight level road increases its velocity from 17 meters per second. So I'm going to make my initial velocity equals plus 17 meters per second to 36 meters per second. That's my final velocity equals 36 meters per second. And that's positive. In 11.9 seconds, my time equals 11.9 seconds. What was the car's acceleration? So first question, I'm looking for acceleration. If I want to find my acceleration with my initial velocity, my final velocity, and my time to get my acceleration, I look at my 4 equations of motion and I notice that one of them says that my final velocity is my initial velocity plus my acceleration times time. So if I plug in my final velocity of 36 equals my initial velocity of 17 plus my acceleration times 11.9, well, I'm going to subtract 17 and then I'm going to wind up dividing by 11.9 will give me my acceleration. And I'm going to get a positive number because this is happening in the same direction as I defined as positive. So that's going to be my answer to the first question. Question number 9 asks, how far did it move while accelerating? Well, now I'm looking for my displacement. So for question number 9, it's asking for my displacement. Well, I still have the same initial velocity and final velocity and time, and now I'm looking for my displacement. Since I have acceleration, I could use any equation that has displacement in it, but I'm going to pick the one just to be safe in case I did some weird math here wrong. Why don't I just stick with the one that doesn't have acceleration but has the other 4 variables? The one that doesn't have acceleration is that my displacement is my average velocity, which is 1/2 v0 plus v times my time. So in this case, my displacement, how far did it move actually is a distance, so that's going to be a positive number anyway. So my distance is going to be 1/2 my initial velocity of 17 plus my final velocity of 36 times my time of 11.9 seconds. And that's some simple math to get my displacement. My third question says, or question number 10 says, what was its average velocity? Answer in meters per second. Its average velocity, V average. My average velocity is going to be my initial velocity plus my final velocity divided by 2, or my average velocity is going to be 1/2 v0 plus v, which was the beginning of this equation because my displacement is my average velocity times my time. So my average velocity is going to be 1/2 of 17 plus 36. And that'll give me an answer for question number 10.